Vsauce, Michael here. 0VU is the ultimate reference point. Or is it? Alright, fellow tape heads and people wondering, why the hell did I buy a tape machine? I'm finally at the video of how to calibrate or align a tape machine, and I've been asked for years to do this, but I have been putting it off for very good reason, and that reason is because for me to do a thorough video talking about the science and theory of recording on tape, and then also show you how to properly align a tape machine with the proper set of tools that you'd be using in a fancy smashy recording studio, this would be at minimum a 5-hour video. At minimum, right? Instead, I'm going to take my usual approach like I try to do in all my videos and take it from a home recordist or a DIY's perspective, and I'm going to try to dispel a lot of the mysticism around it. If you've never calibrated or aligned a tape machine and you do a simple Google search, you're quickly going to start pulling your hair out thinking, I am never going to be able to do this, because the way people talk about it on these music forums, they make it seem like you're performing brain surgery, and you certainly can take it to that extent. You could use the tools and everything, but you really don't have to. You could really, do a poor man's alignment, I'll call it, and get your machine running just fine to record music onto and to make recordings with. So, today's video we're going to be showing the process on this Tascam MS16. I'm going to show the process specific to this machine, but it's going to be very similar to every other tape machine. Some higher-end machines are going to have maybe some more adjustments, an easier way of doing things, whereas some lower-end machines like this Tascam 22-2 over here are going to have less functionality, and it's going to be even harder to align the machine. There's really, I'm really going to talk about the theory here as a broad topic, and if you understand the basics, you'll be able to apply it to any tape machine, and with a little logic, it's really not that complicated of a process. The hardest part is really just doing it for the first time, and once you do it for the first time, you'll be able to do it again and again. Alright, enough talking, let's just get started. Okay, baby. The first thing we need to talk about is calibration tapes, and even something as simple as this can be really overwhelming for someone who's new to the tape world. So I'm going to try to explain this as succinctly as possible. In general, a calibration tape is going to have 4 frequencies on it. The first one is going to be around 1K, sometimes it's 700 hertz. The next one is going to be 10K hertz or somewhere around there, then 16K hertz, and then finally a low frequency, sometimes 50 hertz, sometimes 100 hertz, somewhere around that range. Now, each calibration tape is going to be sold at a different volume level or operating level. This is where things can get a little complicated. So every calibration tape is going to be sold at a specified fluxivity level. If you look at this chart here, there are several options that you could get for your calibration tape. And if you look at the top here, the first one is 180 nanowebers per meter. In short, this is known as the Ampex operating level, and that was set back in the Dizay in the 1940s, and that was, considered the reference point for all tape machines. As time progressed and circuitry in tape machines got better as well, god damn it! As tape formulations got better throughout the years, the fluxivity level of said tapes started to increase. And with the higher fluxivity levels, basically just means the tapes are able to hold a stronger magnetized signal, which basically just means you're able to record a hotter signal on said tape. And the hotter the signal you were able to record, the better the signal-to-noise ratio was of your recordings, thus, increasing fidelity. Now, if you look at this chart here, the first column has the nanowebers per meters unit, and then the column next to it is in dB. So, for example, 250 nanowebers per meter corresponds to a plus 3 dB operating level. Now, everyone uses the plus dB operating levels instead of the nanowebers per meters because we don't want to be called nerds, right? So for the rest of this video, I'm going to be using the plus 3, plus 6, whatever designation. Alright, so now you want to determine what reference level you're going to buy for your calibration tape. The first thing you want to look at is your tape machine and what it was designed for. Most modern tape machines, at least for North America, were designed to operate at plus 3 dB. However, almost all of them, from what I can tell, are able to handle the plus 9 dB operating level without any issue. It's only going to be a concern for you if you have a really low end reel-to-reel or a older tape machine that's just not able to handle it for whatever reason. I really don't think that should be a concern for you. The next thing you want to think about is what tape formulation you're going to be recording on. Now, most modern tape formulas, and when I say modern, I mean like 1980 to present day, you know, at least for multi-track purposes, are either going to be a +6 or a +9 operating level. For example, the SM911 is +6, that's what I use. The SM900 is +9. The ATR tapes, I believe, are all +6 operating levels. So you want to determine, first of all, what tape formula you're going to be using, and then you could determine it from there. Now, ideally, if you want to, maximize the output of your tape and maximize the signal to noise ratio as well, if you have a +6 tape, you're going to want to record at +6 operating level. If you have a +9 tape, you're going to operate at +9 operating level. However, there are some slight circumstances where you're going to want to set your operating level lower than the tape formula can handle. For example, for my case, I record on SM911. However, today and in the past, I've calibrated this machine to operate at a +4 operating level. So that's 2 dB lower than my tape formula can handle. And the reason I'm doing this is because when I'm recording onto my tape machine, it's just me in here. So I am also the musician as well as the recording engineer. And that makes it really hard to set my levels when I'm recording. Let's say I'm recording my piano over there and I'm 30 feet away from the tape machine. I can't see my VU meters. It's really hard for me to set my levels. So by setting my machine a little lower than my tape formula can handle, it leaves a little headroom in there for me for occasional peaks that I'm not, anticipating, because nothing is worse when you're trying to get a great performance and in the back of your mind, you're worrying about whether or not you're going to make your machine, peak from hitting a note too hard, right? So that's why I set my operating level a little lower than I need to. And really, +1 dB or +2 dB, it's really not going to have that big of a difference as you think. And really, I wouldn't stress too much about it at all because whatever reference level you buy, you can easily compensate for a different operating level. For example, let's say you have a +3 calibration tape, but you want to align your machine for +6 operating levels. When you go to reproduce that tape, instead of setting your meters at 0 VU, you're going to set them at -3 VU. And you're basically compensating for that extra +3 that you want. Another example, let's say you have a +4 tape and you want to set your operating level to +2 for whatever reason. When you go to do your operating levels, instead of putting your VU meter on 0, you're going to be putting it on +2. You can compensate that way. It's very easy to do. For that reason, I recommend getting, maybe a +3 operating level, because with any standard VU meter, you'll be able to compensate very easily. If you didn't know it yet, calibration tapes are expensive as hell. So you might be wondering, Mario, do I really need a calibration tape? And the short answer is yes. The long answer is yes. And the slightly more complicated answer is maybe not, but we'll get into that in a second. You can cut a corner and you can reach out, like I did, to a local recording studio and ask them to print some tones on a tape that you have. And that's exactly what I did. I went to Flux Magnetic Recording Studios in Brooklyn, shout out, and Constantine over there graciously recorded some frequencies onto my tape for me to calibrate my machine with. And at first, we set up his machine with his MRL tape at +4 operating levels. Then we printed the tones here. For setting operating levels, this is a perfectly acceptable method as far as I'm concerned. You will be able to get it as close as you will ever need to, especially for home recording. Now, what happens if you don't have the means to acquire a calibration tape? Can you align your tape machine? The answer is still no. However, no one said you need to align your tape machine in order to get it into optimum running conditions. And before all you tape heads start going in conniptions and having seizures on the floor, let me explain my reasoning here. The purpose of aligning your tape machine to some reference on a calibration tape is so that you could take whatever tapes you have recorded and put it on another tape machine, and it should play back at the same frequency response and levels as it does on your tape machine. Now, for a home recordist who only ever plans to record and play back his tape machines on his own tape machine, why should I care? It's not necessary. If you plan on setting your tapes to be mixed by someone else or to do recording in a different studio and do overdubs in that studio over there and then go over there and maybe send your mix downs to get mastered, then yes, you definitely want your machine aligned because you want your tape to play back properly on another tape machine. That's not necessary if you're only recording and playing on one machine. Really, what you care about in order to get your machine running at an optimum condition is that whatever frequencies you print onto the tape on your tape machine, you want it to play back at a relatively same frequency response. As close as you could get it, that'll be fine. In fact, I originally had this tape machine calibrated to an MRL tape, but I couldn't help myself. I started tweaking with it and messing with it, right? And then I couldn't recalibrate it. Yet, I wound up recording this whole album with the uncalibrated machine. And then I mixed it down onto my extremely uncalibrated 2-track machine over here. Both machines completely uncalibrated. However, I was able to produce an album, a whole album, without having them properly calibrated, right? And I must stress, if you plan on playing your tapes on anywhere else, yes, you 100% need to do an alignment. And that being said, just because you're only playing tapes on your machine, you should still strive for wanting a calibration tape. It's definitely useful to get your tape running 100%. Don't get me wrong there, but I'm just saying it's not really necessary from a garage rocker's perspective. And really, as an extra measure of assurance, which you should be doing anyway, which I'm not gonna lie, I've never actually done this, which I really should, is at the beginning of every tape, you should be printing test tones, so if that tape ever does get played on another machine, that machine can be aligned to whatever test tones you have on your tape. I really gotta start doing that. That is pretty necessary. So, yes. I probably upset some people with that opinion, but I don't know. Yell at me in the comments, do what you usually do. Let's move on now. And this video is already getting way too long. I didn't even get to the alignment process yet. Let's get started talking about what you need to do. First things first, you need to make sure your transport is mechanically aligned. That's not the scope of this video. It would be way too long. That's another thing that seems like a really simple process, but it can turn into a nightmare really quickly. This machine has been set up for years and has been running perfectly fine, yet because I got my heads recently relapped at JRF Magnetics, I wanted to go the extra mile and make sure my transport system was still aligned and calibrated and everything. I went through the whole process, and it turned into a nightmare. It wound up taking up my whole Sunday, a whole 10 hours. And really, you know, I could have just left the machine as it was, and it probably would have ran just fine, but I wanted to go that extra mile and really get it as close as possible. I still didn't get it 100% operating, 100% factory specs. It's impossible with these tape machines. Just like any other mechanical system, once things start to wear, and it's been 30 years since it came out of the factory, you're never going to get it 100%. But you could get pretty damn close. That's where I got. The most important thing you want to care about is make sure your head contact is set correctly, because you don't want your tape heads wearing incorrectly, especially if you just got them relapped like I did. You want to make sure that all the adjustments, especially the Azimuth adjustment, is correctly set up, the head wrap adjustment as well, because you want your tape heads to wear uniformly. These tape heads are hard to come by and expensive, okay? That's what you want to do. Second thing is you want to demagnetize your tape machine. If you don't know how to do that, go watch another video. Third thing is you want to clean the hell out of your tape machine. Clean it real good if you're going to start this calibration process. You want your machine to read that calibration tape as best as possible. Really take your time. Get all the nooks and crannies. Clean it well, well, well. Alright, we finally made it to the alignment process. Thank you for sticking with me. I know I don't shut the hell up. Now, the steps as how I'm going to list them is how the manual for my machine tells you how to do it, but there's a lot of variability here, both in the order in which you do these adjustments, the methods, the levels of complexities. Really, there's plenty of ways to do this. Really, I'm trying to teach you the theory of what we're doing here, and once you understand the basics there, you'll be able to do an alignment without having to look at a list. It's really self-explanatory and easy concepts to understand, and after you do it a couple times, it'll be like riding a bicycle, okay? So let's get to the first step. The first adjustment we want to make is the input level for your tape machine, and simply that just means whatever input signal you're putting into your tape machine, you want to get the same output level out. Now, practically what that means is if you're sending a 0 VU signal from your mixing board to, say, track 1, when you monitor track 1 at your mixing board right here from track 1, you want that level to be 0 VU as well. So this is bypassing the tape heads. This is strictly signal passing through the tape machine and monitoring that signal. You want it to be exactly the in as you get out. Really simple adjustment. The second adjustment we want to make is calibration of the VU meter on your tape machine. You have to be a little careful here. For example, the manual for my machine tells me to set a +4 dBm signal as 0 VU on my meters. However, my mixing board is not set up for a +4 dBm operating level. It is an unbalanced -10 dBV, so it doesn't put out that operating level, right? So instead, what you want to do is whatever your mixing board considers 0 VU, that's what you want. You want to send that signal to your tape machine, and that's where you want to set your 0 VU adjustment on your meters, right? So when your tape machine is both reading and playing back the signal, 0 VU there as your meters show, that's what 0 VU is on your mixing board. Okay, makes sense? Let's move on. The third adjustment we're going to make is the peak LED lights on your VU meter. You know, you want them to light up at a specified value. However, we're going to skip this one today because I don't have a proper equipment to accurately set the peak LED lights, and right now the way the machine is set up, they function perfectly fine for my needs, so there's no reason for me to mess with it. And I'm going to be honest, I'm usually pushing my levels so damn hard that my peak LED lights are all over the place anyway. I'm usually not too concerned about it. I'm more listening with my ears, and that's where I go from there. So I'm sorry, we're skipping this step today. So those first 3 steps are really just an initial setup when you first get your tape machine. You should rarely, if ever, have to make adjustments to that. And then you can move on to the actual calibration process, and I know you're excited, baby. This is going to be fun. Well, a little stressful, but fun as well, right? So we're going to throw this calibration tape on and get started with the first step. So with the calibration tape on, we're now going to do the head azimuth adjustment, and this is going to be both for the reproduce head as well as the record/sync head. And this adjustment is just making sure the tape head is perfectly perpendicular with the tape path. If you look at the diagram here, you know, your tape head can be, you know, rocked back and forth one way or another to get that perfect alignment. This is done with a 10 kilohertz test tone. Now that we have the head azimuth adjustment set for both heads, that is the last mechanical adjustment we want to be making. Everything from this point on is going to be an electrical adjustment on each of the track's individual cards. The first step is going to be setting the playback level or the operating level of our machine. So the 1 kilohertz tone on our calibration tape is going to be used for this. And think of the 1 kilohertz test tones as the main frequency for setting levels, right? This is going to encapsulate the middle ground of your frequency response of your machine. You know, the human ear is more designed to hear, you know, frequencies around that range. That's the main body of information that we want to record. So thus, we are going to set our operating levels for that machine. And all this goes back to the fluxivity ratings I was talking about before with calibration tapes. Every calibration tape is going to have a specified fluxivity, and you're going to use that fluxivity to determine where you want to set your meters. If we have a +4 tape like this, and we want to set our machines to a +4 operating level, when we play back that 1 kilohertz tone, we want our meters to be adjusted to show 0 VU. Now we're going to do this both for the reproduce head as well as the record head. The next step, after we set our operating level based upon our 1 kilohertz signal, we are going to adjust our playback EQ response. And for this, we're going to look at the 10 kilohertz signal as well as the 16 kilohertz test tone signal on our tape. And whatever operating level was showing on our VU meters for that 1 kilohertz, we want our 10K as well as our 16K to be as close as possible to that same VU meter reading. So if our meters read 0 VU for 1 kilohertz, we want our 10K to definitely say 0 VU, and we want our 16K to be as close as possible to 0 VU. Once again, electrical adjustment to do so. We're going to do this both for the reproduce head as well as the recording head. The next step is going to be playing the low frequency test tone that you have on your tape machine. And really, there's not an adjustment to be made here. Most machines, I say most machines you can't adjust the low frequency playback response on your cards. You are really just making sure something isn't wildly off here. You want to make sure the low end is somewhere where it needs to be. If it is wildly off, then something's probably not set up right. Maybe you need to demagnetize. Maybe your test tones aren't correct. Something's off. Go back, try again, try to figure it out. But it needs to be somewhere around 0 VU. Most of the time it's not we'll see where we're at with this machine. And that's all you need this calibration tape for, folks. After that, you can take that baby off and put it aside for a rainy day. Now, remember our conversation before of whether or not you need a calibration tape. Now, let's say you don't have a calibration tape. What are you going to do? The first simple thing to do here, since you can't set your reproduce signal levels, is just assume whoever had the tape before you more or less has it in the right place. As long as that's okay, you'll get usable results. I mean, you'll hear if something is wildly off. If your high-end signals on a pre-recorded tape or the tapes you're recording is really low, maybe try adjusting the high-end playback. Maybe that'll make it sound better, right? I know I'm making people freak out right now. Just take it from a garage rocker's perspective. Don't think about it too much, okay? Just record on the damn thing, okay? Now, for the head azimuth adjustment, same approach. If you don't have a calibration tape, you at least want to make sure that your record head is perfectly aligned to your reproduce head. So even if both your heads are slightly off kilter, as long as they're off kilter at the same angle, that should be fine for your purposes. And it's very easy to do that. I'll show that in a later step in the video. Once again, I know you're freaking out. All you tape heads, I know it. But I'm just saying, from a DIY, home recordist, garage rocking, signal thumping point of view, that's how you could get away without using a calibration tape. It's doable. Let's just move on. From this point forward, whatever tape we are going to be using for our recording session, that is what we want to put on the machine and do all our further adjustments with. Now, you might be wondering, if you have the same tape formula, do you have to redo all these steps? You should. However, in the past, I haven't. Listen, I know, once again, everyone's freaking out. In the past, I've just used a new roll of tape that was the same tape formula. SM911 is what I mostly use, and my performance was exactly the same. I don't go crazy. It's just record onto it. Stop going crazy, okay? But anyway, the first thing we're going to do is set the bias level, and I'm struggling not to go into extreme detail of what I mean with bias level and what that actually means, the science behind it, but that's out of the scope of this video. The first thing you want to know is just we need to set the bias level. This is done with a 10 kilohertz test signal. I'll show you how to do that later on in the video. Then after that, we want to set our recording level, and this is done with a 1 kilohertz test tone signal. And what we're going to do here is we're going to send a 1 kilohertz test tone signal from our mixing board to our tape machine. We are going to record said signal, and then we are going to monitor on the reproduce head as we're recording that signal. Now, if you remember, our reproduce head should already be calibrated based upon our calibration tape. So if we're putting a 0 VU 1 kilohertz signal onto the tape when we're trying to record that, it should be playing back at 0 VU, right? If it's not, we need to adjust our recording level in order to either raise or lower the signal being printed onto the tape in order to get the same, 0 VU level. I'm sorry, I'm tripping over my words here. Hopefully that makes sense. We're just adjusting how much signal is being put onto the tape as we record. So if we put a 0 VU signal in, we get a 0 VU signal onto that tape. The next step is going to be the recording level frequency response. And similar to how we did the playback calibration, we first did the 1K, now we're going to look at the high end, and then we're going to look at the low end. So the first step is going to be do the same thing. Instead of printing a 1K kilohertz tone, we're going to be recording a 10 kilohertz test tone onto the tape and monitoring from the reproduce head and seeing what we get. If the level is less than we're putting in, we're going to raise that level with the electrical adjustment. Then we're going to look at the 16K, see what we could get there. And then finally, after 16K, we're going to look at the low frequency, and there's going to be a low frequency response adjustment on your cards, most likely, in order to get that low frequency to record at the level that you want. This is in contrast to the playback adjustment, where most machines don't have a low frequency adjustment. The low frequency adjustment is almost always done during the recording phase of your calibration. Now, for this bias level, recording level, and recording frequency response adjustments, it's not going to be as cut and dry as you would hope. Like everything in the tape world, there's a lot of give and take. It's a very iterative process to get the machine running as possible as you can, because every single adjustment adjusts another thing. The bias level adjusts the recording level, which adjusts the frequency response. It's all interrelated. In the past, when I calibrated this machine, I couldn't get my high end to be near as close as I wanted to. I hope when we do the test today, the calibration today, I'm able to get a better result than I did in the past. But it was so off the last time I did it. But once again, try not to go crazy about it. I recorded a whole album with this machine completely uncalibrated, and I got a usable result. Really, you're looking for compromise here. You want to get the flattest frequency response as possible. It's never going to be perfectly flat, but you can get it reasonably flat. To go the extra mile, instead of doing these test tones, you could use a frequency sweep. You know, you could get an app on your phone to do this, and I would do the same thing. I would record a frequency sweep and monitor it at the same time, and go from 20 hertz to, let's just say, 18 kilohertz, right? And you want to see on your VU meters, when you're monitoring that signal, where there's dips and valleys in that frequency response. It should be more or less, if you did everything right, within -3 to +3 dB for all these frequency response. It's never going to be exactly 0 dB all the way through. This ain't digital. Get it out of your head. Just try to get it as close as reasonably possible. Keep in mind, there's usually a low end bump with tape recording, right? So there's going to be a little bit of emphasis on the low end there. Just keep that in mind. Okay, there are some other tests that are outside the scope of this video. For example, bias tuning, bias trap adjustments. You shouldn't really have to do it that often. Erase ratio. Hopefully your erase head is set up correctly. You shouldn't have to do that often either. Signal to noise ratio analysis to see if your machine's running in acceptable ranges. Crosstalk analysis to make sure the tracks are not crosstalking more than they should be. A distortion analysis. A wow and flutter analysis. Listen, I don't have the equipment to do that stuff. I've never had to do it. I already told you I recorded a whole album. Blah, 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 right? Don't worry about it too much. Just get it running reasonably. I've talked enough. Let's just get to the actual process here. There's going to be more tidbits there. This video is already an hour long. All right. I need to eat something. Okay, let's get started. Okay, so we're finally ready to do the execution here of this tape calibration process. And you have to remember, for all these steps moving forward, that there are multiple levels of precision that you could take these adjustments to. I recommend, if you're just starting out, you know, don't go crazy going super precise. Just get the idea of what you're doing in your head and conceptualize what you're doing, and then as you do it more and more, you'll get more comfortable, you'll get more accurate, and, you know, you'll get the fruits of your labor there. If you're looking at it from like the most scientific perspective, the most accurate way possible, you would use something like an oscilloscope here to set your levels. That would be overkill. You definitely wouldn't do that. I don't think anyone's doing that, right? In a professional setting, it would be a little layer below that, and you'd use something called an AF level meter or an audio frequency level meter. You know, that's a device specifically meant for measuring audio levels, and it's going to take into account, you know, different frequency ranges and stuff like that. Then the step below that is going to be using something like just a digital multimeter, and these are not meant to measure audio levels, so it's not 100% accurate. It'll get you close enough. I mean, you don't have to go crazy, as I said. The level below that is going to be a VU meter, and for a reason I'll get into in a second, VU meters aren't exactly 100% for all frequencies. I'll explain that in a second. That's really the lowest you want to go with the level of precision, isn't a VU meter. And then there's one more level after that. I'll call that the Mario level, and that's when you're kind of just go, that's good enough. And you'll see me do something like that in our first step here. You know, as I said, there's multiple levels. You'll find at what level you want to go to. You know, there's some tape heads out there that go above and beyond to get their machine working to 100%, but at that point, it just becomes more of a stroke fest than anything. You know, it's not going to affect your recordings. As long as you're reasonably in the range where you need to be, it's not going to matter. 1 dB here and there when you're recording something like a drum track, that's nothing, right? Your levels are going to be fluctuating all over the place. Don't go so crazy, you know, adjusting everything so perfectly. So let me show something to you on the VU meter here. And I just want to show you that a VU meter is a little, you know, not as accurate for all frequencies and types of music, and I'll show you that in a second. In the view here, we have my main VU meters for my mixer, and then I have these meters here that are not VU meters. They're these digital LED meters. Now, the signal I'm about to play onto my mixer that's going to be showing on these meters is going to be the same exact signal played at the same exact level. So what we're reading on these level meters should match what we see on the VU meter. So let me play right now. And this is just a full mix song playing from my phone connected to my mixer. Let's go to a section here. Alright, so we have the music playing. I'm going to raise the volume a little bit so the meters on the VU meters are about 0 VU. So right now, the needle's pretty much hovering around 0 VU. On these meters, you know, you can see them peaking a little bit with the red. That's right at 0 VU. Right now, these meters are exactly, you know, showing the same levels here as they are on the VU meter. Now, I want to show you what happens when, instead of playing a full mix song with instruments and everything that, if I just play a steady state 1 kilohertz frequency sine wave. Okay, so you can see right now on the VU meters, I have it set so it's reading 0 VU exactly. However, on these digital meters, if I could zoom in here, it's going to be hard to see, but we're looking at about -7 on these meters, right? So the way different meters react and show levels, you know, is really important, and especially when you're looking at sine waves on VU meters. They can act a little funky and not exactly how you would expect them to. You have to remember, these are all mechanical analog systems. They react differently to different types of signals and transients and frequency levels. So keep that in mind. VU meters are going to be accurate enough for our purposes, but you know, it's not exactly 100% accurate as you would think as like a digital meter would be. Alright? I just wanted to say that. Let's move on. Okay, step number 1, we're going to set the input level calibration for this tape machine. So right now I have a 0 VU 1 kilohertz signal going from my board to the tape machine. I have my tape machine set on, come on baby, on input for the output select. So right now we're completely bypassing any heads. We're strictly sending the signal to the tape machine, and whatever signal is going to the tape machine, it should be showing exactly coming out. Now, as I mentioned before, there's going to be multiple levels of precision here. Really, I could take the time and do each individual track with my VU meter, but for the sake of time, I'm going to show you the Mario way, the Mario level of precision. So right now, on these meters, that's directly showing the levels coming out of my groups that are what's going to my tape machine. So this is what should be going on this first one. This is track 1 and track 8. Track 2 and track 9, track 3 and track 10, etc., right? So instead of going crazy for this video, I'll show you my simple test here. Okay, so over here, I have this meter selector here. Right now, we're showing group 1 through 8, which I just explained before. That's what's going to my tape machine. I have these buttons for tape in, 1 through 8, 9 through 16, 17 through 24. So when I click this tape in 1 through 8, it's going to show me the levels here that I'm receiving at my mixing board from tracks 1 through 8 of my tape machine. So if I click that, I should, if everything's set up right, I should be seeing the same levels. So I would say that's pretty much the same exact level. You can see some of them are flickering here. That's just because the LED meters aren't that, you know, the units it's showing are a little, you know, broad there. But let's switch back and forth. What I'm sending to my tape machine, right there. What I'm receiving back, you can see it's a little higher on track 1 there. See, what I'm sending, what I'm getting back, it's probably about 1 dB, 2 BD higher there. Let's look at track 19 through 16. And just about the same. You can see, like I said, it's flickering a little bit. But they're all pretty much around, you know, -8 there on those meters. Now, for my purposes, you know, maybe I should reduce track 1 and 3 there, so let's do that. Alright, so let's open this trap door here where all the cards are for each track. There should be 16 cards here because I have a 16-track tape machine. And we are going to do all of our adjustments in here with a plastic tool here. You don't want to have a metal tool stick in here. You don't want to short something accidentally. So I'm going to go to track 1 and track 3, and I'm just going to reduce the input level potentiometer. Now you can't see, but I'm watching the meter on my mixing board, and I'm turning until get it to where I want. So right there, that was the slightest adjustment. I mean, I barely made an adjustment there. That's what I'm saying. You know, you don't got to go crazy. I'm making super tiny adjustments here. Now, track 3, honestly, I'm going to leave track 3 where it is. It's pretty much as close as your boy wants it. Honestly, if it wasn't even on video, I probably wouldn't even change track 1. It's good enough. Record on the damn thing, right? You're going to see that's a recurring motive in this video that I'm just trying to tell you guys not to go crazy. Because I think that's, in my opinion, what's the scariest part of, you know, learning about tape machines at first is everyone makes it seem like you're sending some spaceship to the moon. It's really not that crazy. Let's move on to the next step where we start setting the meters on the tape machine to exactly match, you know, what I'm seeing on my mixing board. So we are going to be sending 0 VU as shown on my mixer, and I want my meters here to exactly match 0 VMU. So let's do that. 0 VU, rather. Let's do that right now. Okay, so I have a 1 kilohertz test tone signal, once again, going to my tape machine. I set all my faders exactly at 0 VU, as shown on these fader markings here. And let's go over to my tape machine, see what we get. Alright, so we're looking at my VU meters here. Remember that track 1 and track 9 are coming from the same fader, track 2 and track 10 from the same fader, etc., etc., etc. They're all paired from my mixer. So if we're looking at track 1 and 9, those are both almost exactly on 0. Same for track 2 and track 10. Track 3 and 11 are a little high. It's about 1 dB too high. Same for track 4 and track 12. Now the question becomes, are my meters not set up correctly, or is the faders for my mixing desk not set up correctly? Now you could see, you could really go into a rabbit hole there trying to figure out which one is which. That's why using something like an AF meter or an oscilloscope to accurately measure your voltages, both coming from your mixer, coming from your tape deck, that's the most accurate way. But as I said, for my purposes, you know, within 1 dB, you know, look how much difference I have to move this to get this to be where I need it to be. You see how little of a change there? That little of a change, now track 3 is on 0 VU. Am I going to go crazy setting all these meters? No, they're all pretty much where I want them to be. Alright, so the next step is to set the peak LED light meters on my machine. I originally said I wasn't going to do this because I don't have the proper way of doing it, but I'm going to show a poor man's alignment way of doing it, and let's see if it works out. I've never done this before. So my manual states that after my meters are set to 0 VU, that the peak LED meter, the peak LED light rather, should light after I add 12 dB to whatever signal is shown here. So 0 VU plus 12 dB, these peak LED lights should go on. So the way I set up my board is I basically have that 0 VU signal shown on my main VU meters as -10. So when these VU meters show 12 dB more than the -10 they're showing right now, which should be +2 in the red here, my peak LEDs should light. So let's see what happens. Let's raise the level. It's going to be hard to do both of this on camera. See what happens. So right now we're at about 10 dB higher. No LED lights are on yet. It's a good sign. We're going to raise about 11 dB higher. Now we're at 12. So at 12, one LED started to light. The rest haven't lit up yet. Let's see how much more I have to go. And now they're all pretty much turning on. I'm at 13 dB. So it was supposed to light up at 12. They're lighting up at 13, at least most of them. Some of them still haven't. Oh, there you go. So they're all lighting at 13 dB instead of 12 dB. They're only 1 dB off from what the manual states, and that's kind of a poor man's way of doing it. Plus dB here, peak LEDs. Good enough. Let's move on to the next step. Okay, so now we're ready to do the head azimuth adjustment for both the reproduce head as well as the record head. And normally this is like a 5-minute adjustment at most. It's really simple. However, just like everything in the tape world, this wound up taking me 4 whole days. And I was originally not going to include this part I'm about to talk about because I really just wanted to show you the correct way of doing this. But the process I went through and the things I've learned along the way are actually really important for us to understand what we're doing and the importance of the azimuth adjustment. And it taught me a few things that I think are going to be really applicable to this video. And really, doing this head azimuth adjustment the way I did it is a great way to see whether or not your transport system is aligned correctly. You know, it should be the first step before you do any electrical alignment. The mechanical transport system needs to be, you know, as good as possible, because it's really important for your high-end response or phasing issues for the high frequencies, that your transport system is as steady as possible. So let me explain. One, we have to talk about the principles here of the adjustment we're making. This way you can understand where I'm going from here. So, okay, so here I have a section of tape drawn. I have 4 tracks recorded onto said tape. And as a reminder, the head azimuth adjustment, as if you're considering this the center line of your tape head, it is going to be the angle this way or that way, right? And in an ideal world, your head is going to be perfectly perpendicular to that tape path. So if the tape is running this way across the heads, you want your tape head to be perfectly perpendicular. Now, the way this is done is your calibration tape that you are going to get is going to have a 10 kilohertz tone on it, and each track is going to be perfectly in sync. Now, in actuality, this is kind of a sidebar here. It's actually one giant track when you get a calibration tape, but the principle is the same here. Let's just pretend that it's separate tracks. And the signal is going to be perfectly in phase, perpendicular to the tape, the way it's recorded. So the tops of each waves are going to be perfectly in sync with one another. The bottoms of each wave are going to be perfectly in sync with one another. So when you're reading it correctly and your head is set up correctly, everything is going to be in phase. Now, let's take the extreme example and show what happens when your head is completely out of phase. So let's say your head was like this. Let me draw that out here. So you can see here, when my head is like this, that the bottom track is being read at the top of the sine wave, while the top track here is being read at the bottom of the wave. That would result, if you were listening to these two channels solely, both those two channels, it would be a complete cancellation of sound. It would be completely out of phase, these two signals. That's exactly what you don't want. So the way we make this adjustment is we listen back to our calibration tape and we adjust this angle until we see or hear. I'll explain the two different methods in a bit. You're going to see or hear when these two signals are completely in phase. And that is going to be where your volume is going to be as high as possible. Because when these two signals here are both in phase, that is when the levels are going to add completely and the signal is going to be as loud or as big as possible. Now, when you do this adjustment on a multi-track machine, more than, I would say, 8 tracks, you're not actually going to want to use track 1 and track 16, say for a 16-track machine, or track 1 and 24 for a 24-track machine. You're actually going to use the 2 tracks inwards of the tape. So for a 24-track machine, you're going to use track 2 and track 23. And that's just because the outer edges don't get reliable performance out of the scope of this video. Just know that you're going to want to do track 2 and track 23, or track 2 and track 15, etc. for this adjustment. So, as I mentioned, there's 2 separate methods to do this adjustment. The first method is going to be using an oscilloscope, and the second method is going to be using a VU meter, and they're going to have different purposes and results, and I'm going to explain that in a second. Okay, so for the first method, I want to show you how to do this adjustment using an oscilloscope. And really, most people watching this video probably aren't going to have access to an oscilloscope, but the theory here and how this works is really important, and I think there's something that we could all learn from this, so I want to explain it. So the way you set this up with an oscilloscope is you take your 2 tracks that you want to do your measurement from. So for a 16-track machine, you're going to be looking at track 2 and track 15. And you're going to set the inputs to the X and Y inputs of your oscilloscope. Every oscilloscope is going to have an X and Y setting here. So track 2 is going to be set up to the X direction of my scope. Track 15 is going to be in the vertical direction of my slope. Now, in an ideal world, in perfect conditions, when you play your calibration tape and your head is perfectly aligned, it should look something like this. It should be an exact diagonal line on your scope. Now, if you were a complete 180 degrees out of phase, it's going to look something like this, where the diagonal is in an opposite direction. Now that's like extreme circumstances. Now, if your head is just slightly out of adjustment, which it probably is when you do this adjustment, it's going to look more like an oblong or a perfectly circle shape or somewhere in between. And when it's a complete perfect circle, that is 90 degrees out of phase. Now, when you do this test and you put your calibration tape on, it's never going to look perfectly like a straight line like this. There's going to be some walking, as we'll call it. And you can see like this line, you know, kind of open up like this and waver like this. Hopefully I could show this on camera here. And that's normal. If you calibrate your machine and it looks like that, that's perfectly normal. That's just because, you know, analog tape is not a perfect science, right? The reason that walking, what is causing that, is the minute inconsistencies in your tape transport. And really what's happening is, as your tape is being ran across that heads, it is ever so slightly shifting up and down on that head, and on a microscopic level. The issue is with audio frequencies on tape, the most microscopic adjustments can have that effect. So even if to your eyes it looks like your tape is traveling across the heads perfectly aligned and there's no wavering back and forth, in actuality there isn't a minute movement there. That's completely normal and part of the beauty of tape. Now, when I first did this azimuth test with the calibration tape that I made at Flux Magnetic Recording Studios, it looked something like this. Now, this is what you don't want it to look like at all. If you get your calibration tape from a reputable source and it looks like this is no bueno. Something is not right with your machine. You can see in the video I'm showing here that it's going from in phase to 90 degrees out of phase to at some points 180 degrees out of phase. And at first, I didn't understand why this was happening. I was very confused, and I thought there was something wrong with my transport. And literally, after 3 to 4 days, like whole days of me trying to pinpoint what was going on here, I realized that the way I got this alignment tape done from another, tape machine out of the recording studio is just not the way to do it. The oscilloscope method, if you're going to go that route and have someone else just record a tape for you, in my opinion, it's just going to be too inconsistent. And that's just because, in addition to the minor inconsistencies on your tape machine during playback that causes that walking, that is going to be added to the minor inconsistencies that whatever tape machine recorded that signal for you to begin with. So when I went to that recording studio and Constantine recorded those tones on me, a couple things there. One, the machine we recorded those tones on, he told me he hasn't used in a while. He has a 2-track machine now. He doesn't use the 1-track machine anymore. He hasn't used it in a while. Two, when we put it on, we were getting inconsistent results with the ATR tape we were using, and it kind of turns out as I was doing more of my testing that the quality of that tape is not as good as it should be, and I think that's also what was causing some of the issues. And really, this is kind of why you need a proper calibration tape to do this correctly. To get it 100% right, using someone else's tape is just, it's never going to get you there. You're going to get results like I did, and it's going to be impossible with the oscilloscope method to align your machine this way. Now, the second method to do the head azimuth adjustment is much more simple, and anyone could be able to do it without any equipment. All you need is a VU meter of some sort, and the principle is exactly the same as the oscilloscope method. And basically what you're doing is, there's a couple ways to do this, but I'll explain my preferred method. Let's say you have a 4-track tape, like so. You are going to take all of your tracks and sum them to one channel. So let's pan all of these tracks, say, to the left channel. And we are going to rock the head back and forth, and we are going to watch the VU meter. Now, when you get to the perfectly in phase point, your VU meter should be the highest it is when you're doing this test. And you'll see it very, very easily. As you move your head back and forth, the needle is going to raise and drop, and you'll find the sweet point. It is much easier, in my opinion, than doing the oscilloscope method. And for purposes of home recording, it is going to be fine enough for our purposes. So, that's what we're going to do today, because as I said, with the calibration tape that Constantine made for me, the oscilloscope method was just not working out. So what we're going to do instead, since I want to show you both methods, we are going to set the reproduce head using the summing method that I just described. And then once we set that, we are going to set the record head with the oscilloscope. And the way we're going to do that is, now that we know the reproduce head is where we want it to be, we are going to record a 10 kilohertz tone on the record head. We're going to be monitoring on the reproduce head, and we are going to be looking at tracks 2 and track 15 on our scope. Now, as we move our record head back and forth, it is going to shift at where the phase of each of these sine waves are that are being recorded onto tape. And since I know the record head is perfectly perpendicular where I want it to be, when I get my record head to be perfectly in match with that reproduce head, I should show a signal like this on my scope. So I'm basically using my reproduce head as my reference point to set my record head. And really, I think that's recommended even if you do have a calibration tape, because it is most important to get your record head and your reproduce head to be perfectly in sync. Now, this adjustment, on a sidebar, I know this video is turning into a 2-hour video, but just skip ahead if you can't deal with me talking too much. This adjustment is less important for multi-track recording decks than it is for, say, a consumer playback deck. And the reason for that is that these phase cancellations, like take for example, in a normal recording session, you're obviously not recording, 16 tracks of a 10 kilohertz sine wave, right? You're recording multiple instruments. Some of them are overdubs, some are this or that, right? It's really only if you have, let's say, a stereo set of microphones that this phasing might become an issue where the high end starts to cancel out like this. And really, let's say you're recording a stereo track, a stereo overheads for a drum, for a drum set. And let's take worst case example. If you record the left overhead onto track 1 and the right overhead onto track 16, which I don't know why you would do that, but let's just say worst case scenario. If you did that, you're going to get some cancellations in the high frequencies because of this misalignment. Now, let's just say, on the contrary, instead of recording track 1 and 16, you did track 1 and track 2 for the stereo overhead for this drum set. The angle difference of whatever misadjustment you have on your head is going to be much more insignificant than track 1 and track 16, because those tracks are closer together. You're going to have less phase cancellations. So really, in the grand scheme of things, for a multi-track recording session, it's not super critical. You obviously want it to be as close as possible because your high end is going to suffer if you don't, for the situations I'm explaining now. However, if you have a consumer deck, it's way more important because now you have a stereo signal or stereo mix down you're listening to, and a slight misadjustment to your head is going to create a significant loss in high end. And you could actually make this adjustment, this head azimuth adjustment, on a consumer tape deck really easily without any equipment. You just make the adjustment while you're listening to a pre-recorded tape, a consumer-made tape, and you will hear immediately where the sweet spot is, because the music will suddenly come alive once you get the angle correct. All the high end will suddenly be there, and as soon as you're a little off, they'll start to hear an immediate drop off in the high end. It's actually really simple of a test to do. All right, enough yapping. I talked too much already. Let's do this summing method using my, poor man's calibration tape, using the summing method. Let's do that on camera right now. Okay, so I have the calibration tape on, ready to play the 10 kilohertz tone. I have all my tracks panned to the right channel on my master bus here, so we're going to be looking at the right VU meter once that focuses. And keep in mind, when I play this back here and you look at this VU meter, it's going to be jumping around a lot. A little bit is typical. The amount it's jumping around here is not typical, and it's because I'm using a poor man's calibration tape. If you have an MRL tape or some equivalent and your meter is bouncing around that much, there's probably something wrong with your transport. As I explained before, your tape is not traveling across the heads consistently. You need to go back and look at your transport system. All right, so let's get started. And reminder here, just to show you, I am adjusting. Let's focus. There are 2 hex heads here, and that's where my Allen key is. And I'm going to be tightening and loosening both those set screws to, angle the head one way or another. I'm making really small adjustments. You gotta remind yourself that this adjustment here is really minute. We're not making vast adjustments. I'm just doing that for the sake of explaining it. It's really precise measurements, changes here. All right, so here we go. That's where we're at now. You can see it's moving around a lot. Let me start adjusting. So I just got a drop off there. Now I'm pretty sure where I had it, the head was already aligned. So now it's really low. Let's see if I can get it back up. There you go. You see how it just jumped up like that? Now it's down. I'm rocking the tape back and forth. There's the sweet spot right there. And as I said before, it's wavering a lot. And see, I went back down. I'm making my adjustment somewhere around there. It's a lot of give and take. And the reason you're summing all of the tracks is you're basically averaging all of the phase cancellations, and it makes it a little easier when you sum all the tracks together like that. So I'm getting closer and closer. I really hope you can see this on camera. So right there, I get a pretty stable reading right there. I'm pretty happy where that's at. And keep in mind, you know, the standard tone is 10 kilohertz for this, but the higher the tone, the more accurate your adjustment is going to be. That's pretty good where I have it right there. I'm happy where that is at. That's what you want. You want the most stable reading, the highest reading. That's looking good. Hopefully you can see that on camera. If not, I don't know. I don't know, man. Just make sure the VU meter is as high as possible. All right, so the reproduce head is set. Let's do the record head using the oscilloscope method as I explained before. Okay, so now we're at a blank section of the tape. We're going to make adjustments to the record head. I am sending a 10 kilohertz tone to both track 2 and track 15 to my tape deck. And track 2 is set up to the X coordinate, or the X input on my oscilloscope. Track 15 is on the Y oscilloscope. Now we're going to be looking for a perfect diagonal line. As I said, there's going to be some walking of that line. You'll see that. That's just because of tape is what tape is. All right, so as a reminder, we're still, even though we're setting the record head, we're still listening, we're still monitoring from the reproduce head, because that is our reference. That's where we want to set our record head. And let's just do it. Let's see what happens. All right, here we go. So right now we are almost 180 degrees out of phase. Let's make some adjustments. If I could get it in, let's see. There we go. We're getting closer to in phase. Somewhere around there. And that's pretty close to where we want it to be. Let me make a big adjustment here just to show you. See, that's out of phase, and that's about 90 degrees out of phase. And then that's in phase right there. As I said, there's a little bit of walking, but that's normal. That is normal. That looks good to me. Just make some further slight adjustments. See if we can get it a little better. No. No. Right there. I mean, that's pretty good. It's pretty good to me. Maybe walking a little bit more than I would like. Once again, that walking is due to your tape transport, but I spent a full 4 days at this point making this transport system as best as it's ever been, and that's as good as it's going to get, and I'm happy with it. Both of these heads are adjusted. I think it's time to move on to the next step. Alright, so now we're ready to set our reproduce levels for our tape machine, and this is both going to be for the reproduce head as well as the record/sync head. We're going to use our calibration tape. We're going to use the 1 kilohertz test tone on there. Remember, this calibration tape was recorded at a +4 dB operating level. I want to set my machine for a +4 operating dB level. So I want, when the 1 kilohertz tones to playback, I want them to be at 0 VU on all my meters. Now, keep in mind, just for the sake of this video, just for clarification, you're going to see track 2 here. The needle is going to be much higher than the rest of the tracks. That has actually nothing to do with my tape machine. When we were recording this calibration tape, Constantine's tape machine was having an issue with track 2, and we swapped out the cards on his machine, and I don't think we set it up right, because you'll see that track 2 is a lot higher than every single other track. And like I said, since we were having troubles with that track, I actually think the levels here are like 3 dB higher accidentally on the tape than all the other tracks. So when I do my adjustments, I'm going to account for that, and I'm going to have my meter around 3 instead of 0. Hopefully that doesn't complicate this too much. I just want to clarify what's going on there. Alright, so let's press play and start adjusting. Alright, so I'm going to start on track 1. Track 1's already pretty much at 0 VU. Actually, all of them are pretty much at 0 VU a little bit. Some of them are a little off. Let's make adjustments. Let's start with track 1. This wavering is a little more than I would like, but it's pretty typical. You know, the edge tracks usually waver a little bit, and when we were recording this calibration tape, we both noticed, especially for the 10 kilohertz tone you'll see next, that the tape was recording the signals with a lot of wavering, more than typical. We weren't exactly sure why. Once again, just buy a calibration tape. I don't know. Okay, so let's just make adjustments. Alright, track 1's good. 2, I'm just gonna leave 2 as we said. 3's pretty good, 4's good, 5's good, 6 is a little high. Alright, and if you notice, all the needles are kind of wavering in unison, and to me that indicates that his transport system might not be set up as good as it should be. Number 9's a little low, so let's raise number 9. 11's a little low. 12's a hair low. Everything else looks pretty good. Maybe 7 and 8 are a little high. It's kind of hard to do this on the angle because the camera's there. That looks pretty good. I'm happy with those levels. Okay, so now we're going to do the same test for the record head instead of the reproduce head. See where we're at. They all seem a little bit high. Well, not all of them. This one's a little high, little high, little high, little high, little high. Alright, so let's just make the adjustments. Track 1, lower that a little bit. Track 2, we're going to lower that one a little bit to match what was shown last time. For the reproduce head, it was somewhere around there. Good enough. I know people are getting really upset with me right now, all the tape heads. Track 3, track 4, a little high. Track 5. Now you can see everything was pretty much consistent, which is a good sign. Means nothing. Oh, I'm doing the wrong one. I meant to do track 8 or track 7, but that was track 8. Track 7. That's good there. Track 9's good. Track 10's a little high. Track 10. Track 11's good. 12's good. 13 and 14 are a little high. Why is nothing happening? Am I doing the wrong one? Nothing is happening with that one. It's because I'm doing the wrong potentiometer, that's why. Alright, that looks pretty good. I would say the record head is aligned to my standards. Once again, track 2 is a little off for that reason. Good enough. Next step. Alright, the next thing is going to be setting the reproduce EQ adjustment for both heads. Now we're going to listen to the 10 kilohertz signal. We're going to get that as close as 0 VU as possible, and then we're going to move on to the next step. I'm not going to go through each one as I just did. This video is already too long. You'll get the idea. Okay. Okay, so I made the adjustments for the high-end playback response for both heads. Now, I also have a 16 kilohertz and 100 hertz tone on this calibration tape. Just for the sake of checking it out, I want to see how both of those frequencies play on these meters. And even though there's no adjustment to be made here, I just want to see how well the tape machine is operating and making sure everything is in good working order. So let's skip ahead here. Alright, so this is 16K. This is actually doing pretty good. I'm getting some really good frequency response. They're all around 0 VU. Good news. Let's check out, this is the sync head playing. Let's check out the reproduce head. Reproduce head also doing great. They're all around 0 VU. That's indicating a relatively flat, or a pretty flat playback frequency response. So that's good news. Let's see where the 100 hertz are at. 100 hertz, once again, all pretty good. We have a slow, or a slight rather bump in some areas, I would say. That seems pretty typical, but they're all pretty much around 0 VU. Pretty good. Let's check out the sync head. Now the sync head's playing. Same thing. Everything looks good. All tracks look good, indicating everything is in working order. John French did a great job relapping. All right, let's move on to the next step. Okay, so the next steps are going to be all done on whatever roll of tape you're going to be doing your recording session on. Really, you should be doing it with each new roll of tape. Me, as a home recordist, using the same formula tape. Sometimes I don't. Don't tell anyone though, alright? But regardless, we have a fresh batch of tape on there, and we're going to start with the bias level. Now for this, we're going to be monitoring the machine from the reproduce head. We're going to be recording a 10 kilohertz signal onto the tape. And we're going to take the bias level potentiometer. We're going to make it go all the way counterclockwise to its lowest setting. We are going to raise it slowly, and we're going to watch the needle on the meter rise. And there's going to be a point where it's going to hit a peak, and then it's going to fall back down. We're going to find that peak, right? And then wherever that peak is, we're going to keep turning, and we want that needle to fall a predetermined amount. Now, each different tape formulation, tape machine, tape speed, they're all going to have different levels of over bias, as you call it. A good starting point is 3 dB of bias level. So whatever our peak is, we want to decrease by 3 dB. I know in the past that I need a little more for this machine to get a good frequency response. So I'm probably going to do like maybe 3.5. We'll try 3.5 and see where that gets us. Now I'm going to do this on one of the channels, and then I'm going to do the rest off camera because ain't nobody got time for that. Okay, so let's start with an easy to see channel. Let's go to channel 8. So we're going to do channel 8 here. And let's see what happens. Alright, so we're ready to do track 8. And I have the bias level set all the way to its lowest setting on the potentiometer. Now something I just want to point out. For whatever reason for this machine, when I set the bias level, the needle only slightly moves up before moving down. Every video I've ever watched of someone doing that, it moves a lot more. But for whatever reason, this tape machine, I don't know if someone else with a Tascam MS16 can chime in if you also have this result, but the needle barely moves up before falling down. But your machine is probably going to show more. Let's see what happens. So recording the 10 kilohertz signal. We're looking at track 8 here. So I'm turning slowly, slowly, slowly. It's barely moving up. Now it's falling down. I'm going to go back, see if you can see that. So it's bare. You probably can't even see it on camera. It's like less than a half a dB the needle moves up. Right, so that's the peak. Once I find the peak, I'm going to set the needle based upon, I'm moving this from my mixing board now. I'm going to set that at 0. And then I'm going to keep turning until my needle gets to about 3.5. So I'm turning, 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 turning. 3.5. Let's do number 7 now. Let's go to number 7. I just went all the way clockwise, or counterclockwise. We're starting from 0, and then, or start there. I'm going to raise my level. I'm raising my bias level. Try that again, because it's just hard to show on camera. Moving. It barely peaks. I don't know why. The way this machine is set up, the way the bias level is, it barely peaks before falling down. So the peak's about right there. So I'm going to set that at 0. I'm going to do that until it reaches 3.5. Alright, so now I'm going to do that for all the tracks. Okay, so now the bias level is set for all the tracks at about 3.5 over bias. Now I'm going to set the record level, where we adjust the recording signal going to the record head, and we want it to print onto the tape at a level that we deem 0 VU. So right now my mixer is sending 1 kilohertz at 0 VU to my tape machine. We are going to be monitoring from the reproduce head, and we're going to make the adjustment until our meters show that the reproduce head is reading 0 VU from the tape. Alright, recording level set for 1 kilohertz. Now we're going to do a 10 kilohertz test signal, and we're going to adjust the recording EQ adjustment. Alright, so let's do that. They're all pretty good. Last time I did this, I was getting non-great results, but they're all pretty much where I want it to be. You know, this is always a learning process, obviously. The more you do it, the better you'll get. Wow, that 5 is actually tapped out, meaning I can't lower it. It's actually a little too high and I can't lower it, so I might go back to that one. Usually it's the exact opposite problem I'm having, where the high frequency is too high, or too low rather, too low, but now this one's too high. Alright, so just 5 is 1 dB too high, and I can't adjust it. Let's go back to setting the bias level for track 5. Alright, so setting the bias level for track 5 again. Alright, now setting the record level for track 5 again. Looks pretty good, so let's try the 10 kilohertz. There we go, got a little bit better. Alright, now that track's where I want it to be. Alright, you can see on track 1, getting some wavering, kind of typical. You know, these edge tracks, sometimes that happens. Now it's back, you see, and that's likely due to my transport not being set up correctly. That just happens. Try not to worry about it too much for the edge tracks. If you see that kind of behavior on these other tracks, you might have a bad roll of tape or your transport system is just not set up correctly. Alright, so we did the high Q. Now we're going to look at, let's just, for the sake of it, look at the 16 kilohertz signal. Alright, so now I'm sending the 16 kilohertz signal. Wow, I'm actually getting really good response for 16 kilohertz. If I switch from 10 to 16, 10, 16, I'm actually getting even a little bit more. 10, 16, look at track 7. 10 kilohertz, 16 kilohertz. So that's pretty good. I'm happy with that. 16 kilohertz is actually really steady on all these meters except track 1. So I'm pretty happy with that. Yeah. So, looks good to my eyes. Now we have to do the low frequency check. So now we're going to send my board has a 100 hertz. Let's see where that's at. Alright, so now we're sending a 100 hertz. And wow, it's actually pretty flat. I might not even have to... I might do some slight adjustments on the low frequency adjustment here. Track 1's due, 2, 3, 4, 5, 6. I mean, I almost don't want to touch it. It's how close it is. 12's a little high. Thirteen's a little high. 16's a little high. 8's a little high. I'm pretty happy with the frequency response I'm getting. Last time I did this, it just was not even close. But this is pretty good. Now, what you really should do to go the extra mile is to do a complete frequency sweep while you're doing this test. And, you know, see if there's any anomalies on any of the frequencies. I'm not going to do it on this video just because it's already too long of a video. But you should do that. I mean, I don't know about you folks, but that's pretty damn good. Let's look at 40 hertz just for the sake of it. 40 hertz, I'm getting a slight dropout. But that's pretty good. That's pretty flat. I'm going to cycle through all the tones on my board right now. So we're at 40 right now. There's 100. 1K. 10K. 16K. I mean, that's pretty flat for me, especially for this Tascam. That's as best as I ever got it. So I'm happy where that's at. That is all the adjustments that I'm going to make for today. That's it. I think I was going to sit back up there and finish the video, but what am I going to talk for another 15 minutes? I don't think we should. I really hope you gained something from the video today. It was kind of a mess. I learned a lot with especially that azimuth adjustment. I could probably easily make this video 3 hours, but, you know, I really hope a beginner can watch this video and see that it's actually not all that complicated that it needs to be. You just have to take your time the first time you do it. And really, the harder part is setting up the transport correctly and, you know, doing that. But that's actually more intuitive than anything. You know, just use your eyes and your brains, and you could usually see where you need to make adjustments. And, you know, your machine, your machine's going to have some sort of manual, right? So read the manual and make your adjustments from there. All right, guys. I love you all. I dream of you all at night. I touch myself. Okay. I never know how to end videos. Never know.